So let's start by talking about the basics of how the for loop works in Python, or how iteration works. As you know, if you have an object like a list or something, let's say you have a list of stock names, for instance, you can do a for loop to iterate over the data. Like you can say for name and names, print name. Underneath the covers of that, there's a very specific protocol that is being carried out. What is happening is that Python goes to names and it asks it for an iterator. So there's a special method iter that is executed to do this, and you'll get back an iterator object. Once you have that, what happens is Python will repeatedly call next on it to pull items out. Then this happens until you get a stop iteration exception. So this is the low-level machinery that is being used by the for loop. And in fact, any place that you use the for loop, this is actually happening behind the scenes. For example, if you open up a file and then you do a for loop on a file, what's actually happening is Python goes to the file and says, give me an iterator, which happens to be the file itself in this case. And then you call next on it, and you'll start getting lines of the file coming out. And that will continue until you get to the end of the file, and you get a stop iteration. Everything that plugs into the for loop does follow this convention. And if you're inclined, you can certainly make your own objects plug into the for loop. You can make a class that has an iter method and you implement next and so forth. I'm not going to do that, however, because there's actually an easier way to customize iteration. So let's say you did want to customize the for loop for some reason. One of the ways that you can do that is you can define something known as a generator function. To illustrate, I'm going to make a really simple example just to start, like countdown n. What I'm going to do here is I'll make a function. I'll just say counting from n. And then I'm going to make a while loop that carries out the count. But I'm going to use a new statement that we have not seen before, which is the yield statement. What is going on here is this is going to emit a value. And then I'm going to decrement the loop. I'll put a done at the end. What happens with this function is this is something that feeds the for loop. Like if I were to say for x in countdown 5, print x, what you're going to see is this countdown function feeding values to the for loop. So you see the printing message taking place. You see the 5 down to 1, and then you see the done message. Under the covers, how this works is that you call the function. Turns out that nothing happens. This is very odd, by the way, but you call the function. You don't see any output, but you get this generator object as a result. What this generator object is it's kind of that function in a suspended execution state, and it's not going to start running until you start iterating on it. So the first step of iteration is that you go ahead and you create an iterator. Again, nothing happens. In fact, it comes back saying, well, here's the generator object. The function will not start running until next gets called on it. When you call next, all of a sudden you see the function wake up. It's like, oh, I'm counting down from 5, and then 5 pops out. What has happened at this point is that the function has suspended itself on that yield. It popped out a value, but now the function is just sitting there. It's waiting for you to wake it up again. It's not going to wake up until you call next on it. If you call next on it, it will cycle back around, decrement the value, and spit it out. So now what is happening is that while loop is sort of emitting values. And then when the function is done, you get a stop iteration. So a very kind of convenient way to customize iteration is to define a generator like that. Doing something like a countdown, maybe not the most compelling thing, but you can write all sorts of like little utilities for yourself based on this. For example, one of the Unix tools that I use a fair amount is something like the grep command. This is something that lets you search a file. Like you could say grep IBM in data portfolio CSV. And it lets you find like matching lines. I could do something like that in Python. I could say, hey, let's do a grep for some pattern in a file name. Give me a file name. And then what I could do is open up a file. I could say with open file name as F. For line in F, if the pattern is in the line, yield the line. Well, a lot of indentation on that. But this would become a function that I could use. I could say for line in grep, IBM, data portfolio CSV, print line. And I've just done the same thing that Unix tool uses. Customizing iteration, it's a very cool thing to be able to do that. And generators are one way to kind of plug into that with the for loop. Turns out there's another way to define a generator that is useful to know about. One of the features that we talked about earlier was this idea of a list comprehension. Like if you had a list, you could say squares is equal to x times x for x in nums, for instance, and it would generate like a new list for you. Turns out that there's a variant of this that uses generators. If you change the square brackets to parentheses, you will get a generator object that will produce the same result if you do a for loop on it. So if I say for x in squares, for instance, and print it out, you will see it produce the same kind of output. It's producing squares. This is something that is sometimes useful if you don't care about actually creating that temporary list. For instance, if I say squares is equal to x times x for x in nums, it actually makes a fully populated list as a result. And if I were ever to pass that into a function or something, maybe I don't care about the list anymore. Turns out that it's actually a little bit more efficient to use a generator instead, because it doesn't actually create a list. It just creates an iterator, and then you can sum it up, and then you sort of throw it away. You could even just do it in the sum function itself. One little bit note about Python syntax is if you ever see that convention, with a generator, you can eliminate one of the parentheses, kind of simplify it down. So this is another way of defining a generator, to write one of these generator expressions. We might be able to replace something like this grep with one of those, by the way. I mean, one of the things you could do is you could say, let's open up a file, for instance, and then I could say IBM is equal to line for line in F if IBM is in the line. And then if you did a for loop on that, then you would get the same effect. So these are, sort of some ways, you can customize iteration with either a generator function or one of these generator expressions. Now, one thing I do have to warn you about, generators are a one-time use. If you've made like a countdown, for instance, and then I said for x in C, turns out that I can only do that once. If I try to do a for loop on it again, it doesn't run again. So like a generator lets you iterate once, then it's done. If I want to redo the for loop, I would have to recreate the countdown from scratch and do it again. If that is a concern, like you want to be able to repeatedly do iteration, there is a way to do that using classes that I think is worth knowing about. So let's say you wanted to be able to iterate repeatedly. One of the ways to do that is you could make an object that maybe represents like a countdown. You could say, okay, here's the start of the countdown. And then what you can do is define the iter method actually as a generator. So what you could do is you write iter that carries out the count using yield. Okay, this is the same code as before, just something like that. Turns out that that will create something that you can just repeatedly do a for loop on. So that's also kind of a useful trick to know about, is if you do need something where you just constantly need to iterate, you can make iter itself use this yield statement, and you just use it to kind of drive the iteration process. So in the next couple parts, I'm going to talk about some practical applications of using generators. It's actually a really powerful feature of the language, especially for data processing tasks.